doesn't look like a key.
The tower is actually owned by American Tower Company. The building is actually owned by Alabama Public Television, and the land is actually owned by WTTO Television. It's sort of a joint venture here.
God, it's been a long time since I've been in this room. I remember all this stuff going in.
Wow, this is not
This thing because they you know, he didn't understand about cutting the line lengths right, and it hit a hot spot in there.
Yes.
Yeah. See, this hadn't changed a bit other than they've.
I'm going to show you this is their new fax transmitter.
Yeah.
This is the all solid state up there.
That's the one Herb got down there.
That's what
Yeah.
Herb got
They're
down
still
there.
sitting on the pallet there.
Yep. Yeah. And see, notice his efficiency. He must be running -10, I would guess. Yeah.
This is the new solid state Gates Air Flexiva, they call it.
Yeah. And you note he's got the efficiency here of 56.1%, which should be posted on the transmitter. And of course, this is his main, which is running HD. And then to the right is what used to be the main is the auxiliary transmitter. And it's in a ready standby mode.
Standby is strictly analog only?
Yes, that is correct.
So what is Gates Air? What is that?
This is their transmitter. This does both digital and analog, and that does analog only.
That's just a bundle.
Yes, and they use that as a backup. This is all solid state. That's two.
And Eddie, up in the ceiling, there's all these the switching mechanism that switches between the two transmitters. These are motorized patch bays, not manual patch bays, and by remote control he can switch. Actually, a lot of plumbing. You almost have to be a plumber to be an engineer now. You got to know how to cut TV and put it all together. This is their new transmitter here that actually operates analog and digital together. And that's his old one over there that's just analog only. And he's using that as a backup. This is WZZK building in here.
This is ZZK, right?
Yeah, this is ZZK. But they just went with this one because it can do digital and analog. So that's what he's doing there. So. Frank, is this part of the combiner system? Inside, have you seen those?
Texas on, so when he sees us on the camera, he's not going to panic. That's a little small combiner for STLs and stuff like that.
Oh, okay. What? Oh, yeah. That's the GS encoder.
The satellite dish is up on the walkway up here. I had to climb the tower and walk everything out because I couldn't get up here. Didn't have a ladder big enough.
Oh, okay.
Tom's been good enough to keep it on this one.
Yeah. I've got one of those back at the A.B.A. office that was down at WKNU in Bruton.
actually not bad. Now, these guys, they're great boxes. Yeah.
1,199 amps.
Yes. Kind of amazing.
Very, very low voltage, but very high current. Transmitter running 1,100 amps of current.
Well, and, the other thing with these guys too is that we found at Cumulus, most transmitters pull from the back and exhaust from the top. These guys, especially if you've got the open doors, pull from the front and
Right,
out the back.
right.
So you have to rework your air conditioning. I mean,
Yeah,
this is-
I run into that a lot with stations. When you put a transmitter in and an air condition, the air condition, people that put the air condition in, like for a home or an office, is upside down.
They don't
Because
understand reverse
most transmitters pull in at the bottom and exhaust at the top. Well, a typical air handler will pull in at the top or pull in at the bottom and put out at the top. So you can usually get them to reverse it so that, because that doesn't really make a lot of sense to do it that way.
You can see how much heat comes out, step out back of it and see how
Oh.
much heat's coming off.
Okay, thanks. I know he's got his camera up there. He's probably watching this.
I know it. We were just noticing that the air intake and the output is different. They actually
front.
it pulls
Yeah.
in from the front.
Close it out.
Yeah, see, that's been a real problem with those because most transmitters go out the top and pressurized cabinets, these go front to back and the air has.
Which one would that be?
Mine.
Yours?
I got a tall Thomas.
Are you getting a new one? Are you getting a new one?
I've already got one of those.
Oh, do you?
At JOX FM. It's on the air now.
Okay. Although this is not normally part of an inspection, it's sort of interesting to see how this actually works. Each one of these lines here is an input from a different station. This is, I don't think they have the call letters listed on it, but this is one, see, the 97.3. So these are, you got 1, 2, 3, 4, 5 stations on one antenna. And these are the combiners that allow you to do this. They feed directly in from the different rooms. Every transmitter, every station has their own a transmitter, and these lines go into different rooms and come into this combiner room. And these are filters, and what the filters are for is to keep you from getting into somebody else and them getting into you. So that's the only thing these are for, is to keep, this one will actually put out 97.3, but won't let anything else come back through. It all combines on those outputs where you see the big coaxes back there. That's where all the combiner takes place. But there's actually 5 stations being combined. The signal, from a technical standpoint, the signal is actually split in this hybrid right here, and half of the signal goes through here, and half of it goes into here, and these are actually the actual filter. I should let you do that because you work for this company, but it actually goes through, and these are the way they tune them. So they're tuned, and there's I think I was told there's like 80 dB, approximately 80 dB oscillation from input to output, which makes the other 4 stations that are in this system, their signal is 80 dB down by the time it gets to here. And that's mainly what you're trying to do, is keep somebody else from getting into you. These are what's called balanced hybrids. They got 4 ports, and the one port that's not being used has to be loaded with a dummy load, and that's what that's for, to balance it. All 4 ports have to be balanced up, and so that's what I almost talk like I know what I'm talking about, don't I? This is magic. What's in this box is just really magic. There's no connections between these two. It just sort of couples inside, and they're 90 degrees out of phase.
I see one that's going out to an antenna. So their backup, I guess, coming out of there goes straight to an antenna.
Yeah, I
does it
think,
come through the combiner? Does everybody else?
I believe they do. I'm not sure.
Yeah.
I think they do have backup antenna.
They do have backup, but there are some other antennas up here, so more than likely that other feed is another radio station that's going up to a separate antenna because not everybody is in the panel up here. They could continue in using a balanced combiner system. You could continue to add stations as long as the transmission system could handle the power. There's also what they call a branch-fed combiner system where you're limited to 3 stations, but this is what's called a constant impedance combiner system, and you can continue to add multiple. There are some sites, I think there are 10 or 12 stations.
The one in Miami at the Gannett Tower has 10 stations combined. All the transmitters are down on the first floor, and the combiner's up on the second floor. And they have 10 of these systems set up.
The Jesus stick?
What?
Is that another kind of Jesus stick?
No, that's just a screwdriver to loosen these patches if you got to pull them out. The output that's going to the tower is actually that one right there, that big one. Yeah, it's coming off the output. So what happens down here, you will actually have the input of this station here. It jumps over to here and picks up the output of this one. It jumps over to there and picks, and if you notice the size of the line begins to increase as it goes down until you get way down there, because you're adding the stations as you go along. And it keeps adding and adding and adding and adding until it gets down to the output. And then that's a total of all 5 going up there. And the size of the line dictates how much power that you can actually run through it. So these are very efficient. There's no fans on them. Even though there's a lot of isolation going on in here, it doesn't generate any heat. You can bypass it if there's a failure in one of these filters. You can bypass it by these patches here. You got to shut everybody down and reverse it and feed your signal, which is actually coming in on this one right here. But there's the transmitter, comes down, goes to here, and that goes into here, which feeds into this hybrid. The hybrid splits and feed in here. This is called the wideband port, which is an emergency wideband port. And if this guy's filter died for some reason, he can reverse these and take this one, this one here, and actually feed it right here. Just rotate these around and plug them in up here. Then he goes into the wideband port, and he can still stay on. He just won't have as much isolation as normal. But that keeps him from being off continuously. These are on wheels, so you can disassemble and roll one out that went bad. So luckily, I've never had to do that. But that's an oil filter. That's where you put. These are oil fill.
Isn't there some place where you can do a test point?
To actually read the reflected. No, this is just a dummy load that's used to balance up the hybrid. The way a hybrid works, it's got 4 ports, and all 4 have to be terminated into 50 ohms for it to work right.
Yeah, I mean, you had to put the heat outside. Then really quickly, within a couple of years, we started doing low-level combining where the transmitter generated everything and you could put it into the existing antenna. So that saved a lot of money. There are still some operations that run high-level combining and some that run split-level. And when I mean high-level, separate antennas, or some that split into the same antenna. But the ideal thing is to do everything into one antenna now.
Solid state helped that out.
Yeah, immensely.
Bigger transmitters, you couldn't
Yeah.
really do low level that.
They
Yeah.
transmit one linear.
No, they weren't linear.
Right, that was
You had to
that.
run them class A.B.
Yeah, because if you look,
40, 30, 40%.
yeah, typically the efficiency on low-level combined on the transmitters that are now 10, 12 years old is in the 30s. And if you looked in the room in there on that transmitter, they're running at -10, so they're about 53% efficient. If they were running at -14, they will probably be close to 59 or 60% efficient. That is a major difference in your power bill. Any other questions? Frank's?
anecdotally, what's
Yeah.
the cost in place of one of these systems?
Gosh, I can't remember. It's put it in. But,
They are about, probably for a module like this, around, I'm guessing, and I may be wrong, around 30 grand.
that's what I was.
Yeah. So you're easy for a system like this, you're looking $500,000.
Assuming everything topside is ready,
Yeah.
size-wise.
Yeah. Yeah. And a lot of times they'll split and they do dual transmission lines. This one only has a single line running up, but they'll do two lines.
Join them back.
Yeah, it just is a redundancy and a backup.
I wish we'd have gotten to.
Yeah, I know.
But
Because this thing
you had,
kept growing.
So two in simultaneous, in parallel.
Yeah, and there are actually two panels on this tower. There's the one at the top, and then there's another one that's a low power panel that does a bunch of translators. Are we going to see that one? Is that?
you can see. Well, if you go to my site, you'll see a bunch of translators, and you'll see ERC. Also.
Okay, I couldn't remember where that one was. So,
And then
okay.
there's some other translators. They're all over.
Yeah, they're all over the place. But this one was one panel that was built primarily to do translators and some low powers, and it was all a separate combiner.
I don't think they even thought about translators during this time when they put this one in.
No,
It wasn't translators weren't a factor at that time.
no, not at all. So you see the big brother, and then you'll see the baby.
Cute.
Yeah,
What market number is this?
Number 60.
Oh, wow.
yeah.
We used to be 44.
But man, this is some large market class up here. This is beautiful. This is
Oh, yeah.
beautiful.
Well, it's an ideal site
Yeah.
because of being on the mountain. So we're going to your site now? Okay. All right.
How many stations are here on this mountain?
Oh gosh, I don't know. On this mountain, it's everybody really. Yeah.
It's all the television stations.
All the TV, all the FM, yeah. Most of the translators, everything's here, yeah. Okay, we're going to move on to the next site.
And they don't interfere with each other.
No, that's because these filters, they filter as well as combine. So they keep the stations out of each other. Now, you have the same stuff in Atlanta.
I'm
The
drowning in overload.
the Summit site, the old Summit site that's downtown, you've got Star, WSB, V103 at that site.
And most of the radio stations on Sweat Mountain,
I'm sorry?
County.
Oh, no. There are very few radio stations. Most of the radio stations are downtown. Yeah, yeah. You've got the other group is the Richland Tower that's right out there off of Briarcliff. Yeah, that's where a lot of the TVs and the other FMs are located.
This one.
So, and then there's some.
Really more off of Cheshire Bridge than Briarcliff, or is that right?
That's AM on Cheshire Bridge. Yeah, yeah. Most of the TVs are on Briarcliff, and then right there downtown and toward Interstate 20. All those tall candelabra towers. Towers on down the mountain ridge there. And there are a couple other, the other two TVs are over here, and there's a couple of FMs on those, public and stuff like that. I would just say take a quick look. A lot of these are low power transmitters right here are for translators, so that would be operating at 250 watts here on the mountain. For example, you have HD3, which is 105.3, you have 96.1, which is K-Love. Those would be operating from that location, and they're going into one of the antennas up on the tower. This is iHeart's corner right here, and then what we just passed is Frank's transmitters right over here. But these are all low power and HD operation right here. Excuse me.
Oh, yeah.
So Frank, did you have customized the...
WHT, which is our urban station.
Oh, okay.
107.7.
Oh, that's the one that used to be
The Win.
Yeah, you're right. Yeah, years. That thing used to roll into Atlanta like
Because
gangbusters.
You know what's so funny about it? It was a full class seat.
Yeah.
On a big 800-foot tower out in Palmerdale, Alabama.
Right.
20 miles from Birmingham. You could pick it up in Atlanta.
Yeah.
But you couldn't pick it up in Birmingham.
Oh.
That's why we moved it back.
Yeah. Well, that would make sense.
Yeah. And we dropped it to a C1. And it's an urban format. And I said, if you want to compete with Kiss and Jams,
Yeah.
you're on the same antenna.
Yeah. All right, everybody. Just quickly, so because we got TV to see as well too. Again, iHeart's there. This is Cumulus here. There are some translators in the racks there that when you put his new tube in, that way you can keep up with it. So that's part of his maintenance. That's part of the requirements of putting the efficiency on the transmitter. Of course, he's got forward and reflected meters here. He's got a thermal sentry here. This is part of his remote control for verifying his temperatures in the room. This goes to the transfer switch, and of course there's a modulation monitor here and the exciter, and as you can see, they both read pretty close together. And so if I was doing an inspection, they didn't have a mod monitor, but they did have a current exciter, I'm going to look and see what the readings are. Now, something we didn't mention, most stations do RBDS, data for your car radios, so you're allowed a few percent more in modulation to compensate for that. So if you might want to inquire, if you look and the station's running a little above 100%, which Frank's not, or that looks legit to me, almost too legit, Frank, then you're running RBDS, aren't you? Yeah. He's just one of the good guys. But he
lost. The modulation wars are over with.
Yeah,
They should be.
They really are. So, but you may
that's
walk
Nashville.
into some places and find that it might be hitting 105 occasionally. If they're running RBDS or something, then that's legit. Otherwise, I mean, I do the same thing. I try to run 100% because it doesn't make any difference. It's all about the programming. But again, this is an older TFT monitor. It's actually a great monitor because I use one of these as a test instrument because you had so many functions on it you could test stuff. So this gives you a way of looking both power levels, modulation levels, and so you know what's going on in the operation. And of course, Frank's got a notebook somewhere around here, some logs right over here on the shelf, and you've already seen some of the maintenance logs, so we won't look at those, but you get the general idea. The Continental here is his backup transmitter. And so in an emergency, if this went down or he's changing the tube and doing maintenance, he can switch them remotely or locally right here through the switch.
Extra allotment for compensation for RDS?
It's for RDS 3%.
What is it, a half a
Percent, yeah. So you would
It's 0.5% per percent of
percent,
injection.
right. So technically, if you're running 3% injection, or if you're running 5%, you'd be running 2.5% more modulation would be the way it would
You're
run.
allowed to go
Yeah.
up to 102.5%.
Right,
Unless
exactly.
you're a public radio station and you're running radio reading service.
Yeah, and then
Another
yeah,
subcarrier.
Yeah.
Subcarrier, then you can do 105.
that's
Oh,
correct.
wow, you don't have
Yeah,
to back it out. You go
right.
you
It's
go up.
100%.
yeah, you get it's different for
It's cumulative. That's great.
yeah,
I did not know
but
that.
on the data it would be 0.5%. So.
There is a situation where if a station is running in mono, maybe they're a sports station or a talk station, they can actually turn their stereo pilot off because you don't need stereo.
Right.
Somebody, doing a sports cast, the pilot injection for stereo is around.
But everybody wants it in stereo just so that little stereo light will come
We
on.
had an issue on our talk stations before we turned them to talk. That were running stereo. Their music station had a lot of multi-path over on the other side of the hill over here. And when we turned the pilots off for talk, it went away.
Yeah.
Fascinating.
Yeah, there's another scheme that's being used by a lot of the processing companies, and that's where they use single sideband for your stereo as opposed to dual sideband. And I've actually experimented with it a little bit, and it really does make a difference. So it does work, if at least I felt like it did. But those are some of the things that you can do. You just bought it. It's only one stick. That's what, $900?
$1,000.
Yeah, $1,000 there. So Frank will take a check or a credit card. But anyway, so some people are experimenting doing single sideband to help some multipath problems and help that signal get out a little bit further. So. TV?
Yeah, you're not running HD here.
No,
George, okay.
no. We saw the HD over there.
Yeah,
You don't see it because it's hidden.
Right.
it's hidden. Yeah, it's got what, yours or his?
It is.
Yeah.
Did you mention about this is a co-owned site and the tower is owned by somebody else?
Did not mention that.
They are responsible, not at a normal site, a single site that you own, you're responsible for the tower, you're responsible for the tower lights and the tower painting. When you are a tenant, like he is here, that this tower is actually owned by American Tower, I think. And so they are in charge of maintaining the tower and keeping a watch on the tower lights. And I don't know if they notify you when there's a failure or not.
No, they don't notify me when it's a failure, but what I'll do is I'll get a call from the site manager that's saying, hey, they've got to go up the tower to do tower lights, lower power.
Yeah. Yeah, actually, American Tower has a NOC in Franklin, Tennessee. It used to be part of Flash Technology, and they monitor all their facilities, all their towers at that NOC. There are multiple people there. They constantly polling sites, checking lights throughout the day and night. So they do a really good job of monitoring so they know what's going on at these sites. And they also poll temperatures, alarm systems. I mean, it's quite sophisticated. So they do an excellent job of it.
Do they provide the stations with logs for that? So if you go in and inspect, they don't,
No,
there's
no,
need?
you don't need
Not
it.
in
If
the
I'm
store.
going in and inspecting a station, or Larry's inspecting, and it's an American Tower site or is a co-owned site by another company, it's their responsibility. We're only inspecting the station licensee. The commission can go inspect American Tower and those other companies. Most of those companies, though, are very proficient and do a really good job of maintaining their sites and monitoring the tower lights because
Their business makes
it's a real it's a serious business for them. But that would not be something we would look at if it's co-owned.
Frank mentioned something that's actually on your license. If you have to do any work on the tower, where the tower crew's got to go up in the vicinity of your antenna, on the bottom of your license, there's a paragraph that says you agree and you acknowledge that you will lower or cease transmission for safety reasons when a crew is up there. So as Frank said, if they've got to go up and do work on the tower lights, all the stations have to go down to a lower power. It's if you look on your license, I think the very last paragraph mentions that.
No, it's that way now. The other thing is that while this doesn't involve you in the way of inspection, but if you're ever dealing with a crew going on your tower, be sure that they have a safety plan, be sure that they have climbing plan, and be sure that they have an artometer with them to check RF just to be safe, because there's a lot more on that tower usually than just your FM antenna.
There it is, the last paragraph right there.
Yeah.
The permittee and licensee, in coordination with other users of the site, must reduce power or cease operations as necessary to protect persons having access to the site, tower, or antenna for radio frequency electromagnetic field. That's RF is dangerous.
Yeah.
Oh, absolutely.
Even though you don't think about it, I think it initially affects the eyes. Just a lot of RF up there, and most, as he said, most tower climbers will actually wear a sensor in their pocket that has an alarm on it, and if they get up around where there's too much RF, that alarm will go off and they'll come down.
Frankly, any stations that I do any work with, if there's a tower crew on the tower, my equipment is turned off.
Absolutely.
Period. I don't buy the old story, I'll reduce power to a kilowatt or something like that, and the guy climbs on by the antenna. I just don't take those chances.
Yeah, if it's on, it can go to full.
Yeah,
If it's locked
exactly.
out, it can't do much.
That's exactly
Now,
right.
this site, I believe, and we can ask Frank, but I believe most of the stations have an auxiliary antenna much lower.
And they can climb past it and then go on up.
They can go past the auxiliary, turn that one on and turn the main one off,
Yeah.
and then everybody's happy, you know. And
Yeah.
you lose a little coverage, but you don't lose somebody's life with all the RF.
And same thing with AM. I've seen guys in the old days want to jump on the tower and they'll climb it at reduced power. RF is RF anyway.
That's right.
Everybody ready to go to TV?
Oh, good deal.
All right.